on the home page. Okay, so we're going to go ahead and we are going to go over the 1.2 notes. If you did not take them, you are not setting yourself up for success. We do need those vocabulary terms. You need to understand what all those terms mean, how they're expressed, and those sorts of things. We're just going to go ahead and start at the beginning. I've uncovered all my boxes that I normally have covered, so I want to go through it a little bit quickly. So everybody raise your 1.2 notes in the air so I know you have them with you. Everybody raise your 1.2 notes in the air so I know you have them. That was yours. Okay. Vivian's got hers. Darren's getting his. Colin doesn't have his. Where are yours? You didn't do them? Okay, so okay, then you did that. So if you didn't do them, remember this was the last week I'm taking later side. So do them tonight and turn them in. Anything that you haven't turned in, this whole 2 weeks, turn them in tomorrow and I'll give you full credit. But that should be sealed after this week, okay? If you just forget to do something, you should still do that assignment, but you won't get credit for it. Okay, but remember, I do drop 2 grades because I know stuff happens sometimes. So every quarter I'll drop 2 of your assignment grades. If you just forgot to submit it, or if you had a late night, for some activity you're in, you didn't feel well, you still need to do that activity or that assignment, those notes, that worksheet, because that's in practice for the test, right? But I'll just excuse 2 assignments at the end of every quarter that don't count against you. Fair enough? But we don't do late work after tomorrow. Okay? Full 2 weeks. Take it any way I can get it from you for the first 2 weeks. After that, we go by our normal procedures. All right, so geometry is based on these things, postulates and axioms. These are accepted statements of fact. All the things that we learn are going to be based on and fall within the parameters of a postulate or an axiom. So it's something that is true. We may not know why it's true, might not be able to explain it, you and me, but it is a true statement of fact, and that's the rules we go by. So now we're here in the section where there are 3 undefined terms in geometry. So what does it mean, the undefined? Especially when you look down here at point, it says the 3 undefined terms, point, line, and plane. DSC will probably ask you that. That's a both back of question, easily answered if you're paying attention, right? And something we'll review before you hit POC, but there are 3 terms that they consider undefinable. And yet, here we go and kind of define it, right? It's more of an explanation though. So the point is just a location. So it's kind of like saying we're going to Panama City. Panama City is a place, it's a location. If you look at a map, you can see lines. But when you go to Panama City, do you see lines down on the ground? No, you don't, right? Because Panama City is a location, and a point is a location as well. So the dot represents that location. They can be on a coordinate plane. They can be anywhere, right? It just represents that location. So this is point B. That dot represents the location. The dot is not really the point. Okay? You good? We do name points with capital letters. So the next one we talk about is a line. The line has to be straight and it goes on forever in both directions, right? Also, a location, but it's an infinite location, right? It's just a straight line forever. Okay, as far as you can imagine in this article, right? The way this is important, so this is what we would represent a line as. So we see 2 points in there. So there's an infinite number of points in there. We see the 2 dots that represent 2 points, but really there's an infinite number of points. We could put a point here and a point here, and it would be the same line. Okay? Way that we name lines, so if we're reading something on a worksheet or on any of the resource, how do we know we're talking about a line? Well, there'll be capital letters. Any 2 points in a line, you can name a line by, and we put this little mini line on top of it. A little bitty miniature line. We can name this line RF or SR. Another way that you can name capital lowercase letter, and it's supposed to be cursive. So if you didn't put that in your notes, I might not be in your notes, but you'll see this is line L. You could also say it on line RS or line SR. If points are on the same line, they're said to be co-linear. If you work at the same place, you are co-workers, right? So a co-worker means you work at the same place. Co-linear means on the same line. Non-collinear is what non means. They're not on the same line. Easy peasy. Through any 2 points, there's only one line that we can draw through it. Okay? This is a line. We draw a line through these 2 points. If I draw a line here, do I go through point F? Is there any way for me to get to point F? Except for that, right? Only one line that you can draw through 2 specific points. The intersection of 2 lines, if you imagine, it's one location. They only intersect in that one location or that one point. Does that make sense, Colin? This is point E. That is the intersection of those 2 lines. Any questions? The plane is a little bit harder for kids to understand. You probably have not worked with plane as much as you work with points and lines. But a plane, I like to kind of imagine, it also has the thickness, the length, the width, the height. If you kind of imagine the location that goes to this piece of paper and extends out, it's almost like if I was standing below this plane, so this is in, it would be like a flat ceiling. Like this ceiling is part of a plane that goes on forever and ever and ever in every direction. Does that make sense? Okay. The way we name planes, I'd like to think. Oh wow. The way we name planes is with any 3 points on that plane that are not in a line. They're collinear. So we only have 3 points that are illustrating on this plane. This is plane M. So we can name this plane as ABC. We don't have to put any other indication. If we refer to a figure with 3 capital letters, we should know that it's a plane. Okay, it's not going to have a line. It's not going to have a picture of a moving plane over it. Okay, we should know that that's a plane. It can also be named by a capital letter, and it really should be cursive. My plane has a non-cursive name, but they're supposed to be cursive. Okay, so if you did not write that on there, make sure you know it's supposed to be cursive. So just like you can only draw one line through 2 points, you can only one plane can go through any 3 non-collinear points. If any 3 points are not on the line, you can only get one plane out of that. Does that make sense? And finally, you can work at the same place for co-workers. If their points or lines are on the same plane, they're coplanar. If they're not, they're non-coplanar. Okay? Intersection of 2 planes, so if you imagine not 2 airplanes, don't imagine that would be bad. The intersection means where they touch, right? So if you imagine that these 2 papers are planes and where they cross, where they intersect, the points that they share would be a line, an infinite line, one line. So far, so good? Any questions on our 3 undefinable terms or non-defined terms? Okay. If you did not watch the video on that, I'm having trouble with my sound. That's another reason why we're going over in pretty great detail, because the sound doesn't work on it. But Swan and Helen, I know for sure need to watch that video and take your notes, okay? Please. Instead of all points in 3 dimensions, we think of space as outer space, right? Or how much space is there in this room? Or how much space is there in your car? Do you have space for another person, right? in geometry to set up all points in 3 dimensions. So it would be, for our purposes, basically length, width, and height. All right. This is a rectangular prism. It's a 3-dimensional figure. Has length, width, height. So they like to use these 3D figures for us to illustrate our knowledge about these geometry terms we just learned. So the first question is, how many planes are shown in this figure? Well, these are pretty defined rectangles, which means technically they're not planes, but they are part of a plane, and that's what they want to know. How many planes are illustrated by the sides in this 3D prism, this rectangular prism? There's 2 fronts, or front and back rather. There's 2 ends, so we're up to 4, and there's a top and a bottom. Every side in that 3D figure represents a plane. So we can name any side with 3 points. Okay? So it says name, let's do this at first, name 3 coplanar points. We have 6 planes, so we can name any of the planes that is on we put a name. This one that I have uncovered here says ABC. So ABC is at the top of the rectangular prism, and they named it with the point ABC. They could have named it with the point BCD, and that would have been okay. So it still named the same plane. Okay? We could have named DHG, that's the plane that goes to the front of that rectangular prism, or this lies inside that plane. Fine, you good? Yes. We could name it GHC. All right, several ways to name it. There's several right answers there for that question. A lot of right answers for this. There's only 3 collinear points on this diagram. That's G, J, and S. Okay? There's not a dot, a J, but they're still indicating these vertices are points, locations in the line, and there's a point J there. Okay? Xavier, you good? Yep. Okay. Line segments work with a ton of line segments, correct? We work with planes, but to be honest, but not nearly as much as we work with points, lines, and line segments. We do need to know all the things we talk about with the planes, but the points, lines, and line segments, we work with those all the time. A line segment is part of a line. So PQ is a line segment. If PQ is part of line PQ, we define that as a certain length, certain part of that line. This is not in your notes, I don't think, so let's add that. Only one of the 3 undefined terms can be measured or given a length. The segment is the only thing that has a beginning and an end point, a start and an end point, so we can measure that in length. We can measure that part of that line. You can't measure a line because it's at an infinite length. This particular line segment is PQ. You see that it's named with that little miniature line segment over it. If I see this, I know this is segment PQ. I could have named it segment QP. That would have been fine. That would be correct. That is accurate. You don't have to put a little dot from the segment on top. I prefer that you didn't. But what if they just give us the PQ with nothing about it? That means that's the length of segment PQ. If you don't have length of segment PQ there, make sure you do. I think you do on that one. So, yeah. Any questions on this part of the line segment part? Good. Good. Okay. Now, array is also part of a line. But array only has one endpoint. So that means it has it's infinite. You can't measure array. It goes on forever, but only one direction. So this, so we have here, that's array PQ or array PR, right? But it has to start with the endpoint. Even though it's the beginning point. We might think of it as a beginning point, but really we're also calling it an end point. We call it end point. This is where it starts and it goes on forever. Okay? We can name it as PR or PQ or PR or PQ. We cannot name this segment as QR. That's a different segment. There is not a segment, a different ray. So there is a ray QR in this ray. Okay? But this ray would be considered PQ or PR, ray PR. And it's got a little mini ray on top. Let's see, right? No dot, just a little ray with no dot. The order of the points indicate the direction that it's going, which really means that it has to start with the endpoint. So while the VA is going left, we know that the B is the endpoint, right? Also notice that when we represent this ray VA, we don't put the arrow going that way. The arrow always goes right. Okay? So what would it look like if we had two rays together? What would it look like if we had a point C here and another ray going that way? Watch the video. Anybody know? What's it going to look like? I'm going to show you what I'm talking about. Beautiful. Now what do we have? A line, right? So these are opposite rays. Ray VA and ray VC. Those bring us to that opposite rays part of the note. Opposite rays are aligned. Right, so you're part of the line, the same line. So if we describe something as in opposite rays, we know that these two rays share the point D. One of them starts at D and goes to E, one of them starts at D and goes to C. You notice they both have the same little indication over them. Any questions on rays? Opposite or regular? Okay. So we are at the end of basically our vocabulary notes. Are you good? Raise your hand. And then you can go ahead and follow along with this. You can just watch the part for the notes if you haven't done that, the 1-2. Okay, so we have notes and we have our worksheet tonight. We will finish our notes in class, but we probably won't have time to start our worksheet. A lot of times we will, but today we won't. We're going to squeeze it in here up to the end. So we are going to be measuring segments. So we said that the only one of these terms that we've been talking about that we can actually measure our segments. So that's what we're focusing on today. Something else I've thought about. You know, if I blank my notes, my thing is there. Here's a bunch of stuff on it. Typically, it's going to have the homework that's on there. This is Mrs. Braden's format. She keeps a notebook and she has to fill in all that stuff. But I don't have you guys necessarily keep a notebook that I'm going to grade. I don't select them and turn them in. You can put whatever you want in there, but you probably will say the correct homework assignment on your notes when you have them printed. Okay. Distance. So we have negative distance? No. Nope, no negative distance. Distance has to be a positive number. So distance on a number line is what we're going to start with. We're going to be measuring distance on the number line and then measuring line segments on the number line. So the distance on a number line is absolute value. Remember that absolute value is the distance from 0. So here, this is equal to absolute value of the difference of the coordinates. So absolute value, those are the absolute value symbols. So it's 1 point minus another point. So that's how we find the distance. We're already using our vocab here. This RW, we have to know that represents a segment, and what they want us to find 11, they want us to find how long is RW. So if we look at W and R, we're going to find the absolute value. So the first point is -2 minus the second point is 4. So remember the absolute values symbols are like parentheses, and if they're grouping symbols, we have to do what's inside the grouping symbol, and then we take the absolute value of it. So -4 times -2 equals the absolute value of -2 minus -4 equals the absolute value of -6. So now, how far is -6 from the number line? 6 units. -6 and +6 are the same distance from 0. If you forgot what absolute value is, that's what it is. Distance from 0. We plug in our points, we evaluate that difference inside, and then we take the positive basically of that. So the distance or length of RW is 6. For XY, we're going to do the same thing. The first point is 0, minus the second point is 6. That equals the absolute value of -6. And how far is -6? We just talked about that 6. Does it matter if I put Y first and X second? That's not matter. You'll get the same thing, okay? You can put those points, that doesn't matter. Yes. Okay, so remember, absolute value means distance from 0. So -6 is what we evaluate the points at, the different term, but now we're going to take the absolute value. So we're going to say, how far is -6 from 0? 1, 2, 3, 4, 5, 6 places from 0, right? So we always, if you just keep it, it's always going to be positive. Whatever this works out to be after you do the math, just take the positive. The distance has to be positive, it can't be negative. Figure? Because that's how we find the distance. You mean, why don't we do 6 minus 0? That's the formula, yeah. 1 point minus the other point. So endpoint minus endpoint. Out? No, it's a good question. So what if we did these in different order? So let's put Y first and X second. We could name this segment YX, right? So let's take the absolute value 6. Now let's subtract that coordinate for X of 0. Now we have the absolute value of +6. Well, the absolute value of positive or -6 is the same thing because they're both the same distance from 0. So now, whichever way you do it, Dallas, you get the same answer. Okay? Endpoint minus endpoint, it doesn't matter which one is which. Then we just take the absolute value of it. Our leaving a midpoint might be, what does mid mean? Middle, halfway. So, if I say I want to meet in the middle, and I'm talking about my study lives in Denver. I forget. I think it's like 2,000 miles, 2,200 miles to Denver. If he says, okay, Mom, I'll meet you in, so if I say, okay, Blake, I'll meet you in Pensacola. Pensacola is only 100 miles from me. 2,100 miles from me. We're not meeting in the middle of it. It's only in the middle. If my distance traveled is the same as his distance traveled, then we're in the middle. So that's what we're talking about here. Midpoint, the number line means we're going to find a point that is exactly in the middle of the two endpoints. We're going to find the point that is the same distance from that point to either endpoint. Okay? That's what we're writing down. Oh, that's the wrong thing. The midpoint. Write those words, Helen. Anything that I write, y'all write. You get credit for your notes. Right now, I told you I'm going to give you credit. I'm going to give you points for just copying what I copied, turn it on Chandler. Eventually, we might not get credit for notes, but I want to encourage you at first to make sure you're taking good notes. So the midpoint is exactly in the middle, and it divides that segment in what we call two congruent links. Also, you can call them two congruent segments. By putting a point in between two other points in a segment, you create two segments out of that one segment. So we can find that by adding the two coordinates or points on the number line and then dividing by 2. It's an average. So here we took the absolute value, the difference of those 2 points. Here we're going to add the 2 points and divide by 2. So averaging those 2 points. So you see points R and W. Here's W, here's R. What point on this line is exactly in the middle? We could count because these points are close together. But what is one point where it's negative 3,422 and the other point was 1,415? How can we find that midpoint without counting? We can use a formula. We're going to use small numbers to illustrate. So we're going to take W. We're going to need W is negative 2 plus R is 4 divided by 2. And the order doesn't matter. Remember, we can name this segment as segment WR. So you could do 4 plus negative 2 as well. Is that your question, Dow? Great question. So that's going to be 2 over 2. So the midpoint of segment RW is 1. And you'll notice this second has a line number. That means we were not trying to find out how long it was. They asked us to find the midpoint. So it looks like, well, we figured out algebraically that point has to be 1. So let's put a point on 1 and see. If I count to the right, 1, 2, 3 to get to R, 1, 2, 3 to get to W. Exactly the same distance from either endpoint. That's what makes it a midpoint. Now we're going to do the same thing with X, Y. So X, 0, Y is 6, and then we're going to divide by 2. So remember, the division symbol is also a grouping symbol. We do one from the top first before we divide. Add 6 and 2 to get 6. 6 divided by 2 is 3. So if you want to see, y'all don't put this one on, because I have different colors, and mine, I think it's not as confusing, but I'm going to put a point on 3 and let you see that, yes, it is in the middle. 1, 2, 3, 1, 2, 3. That midpoint is the same distance from either endpoint. Any questions? Nope, it could be a decimal because while the endpoints are the number I would normally mark with integers, there's an infinite number of points in that number line. Fractions, decimals, and such are all included in those on that line. Okay. This is our first postulate. Remember we said at the beginning of your notes, 1-2, a postulate. This is a statement of fact. They're telling us that if we have a segment, we have 2 points. We have points A and C, those are endpoints of a segment. If we put point C squared between those 2 points on the segment, we can add this segment is created, to this segment, it'll equal the entire length. Right? So the segment of those together, added together, equals the full segment. So the part plus the part equals the whole. When you put a middle letter in there, you create 2 parts. So now segment AC is made up of segments AB and BC. So segment DF is made up of segment DE and EF. Okay? That makes sense? All right, so we could use that postulate if they give us certain information about segments, the whole segment, the part of the segment. We can use that to find missing parts. So, for example, in example 5, it says if DE equals 2 and EF equals 7, then DF equals what? That's our question. So, especially where you label your picture, label your diagram. They tell us DE is 2, so we're writing 2. They tell us EF is 7, so we're writing 7. We use this postulate. Now we know that 2 plus 7 actually equals DF, and that's 9. So far, so good? Pretty Captain Obvious, right? If DF equals 41, so now we're talking about the whole thing. DF is the whole segment. They're going to give us the length of the whole segment. They're going to give us the length of part of it. So I'm going to use the bottom. You can draw another segment if you want, or just label on the bottom. So what if DF is 41 and EF is 33? How can we figure out how long DE is? Miles? 38? Yes, totally subtract miles. Yes, so we take the whole, the 41, and subtract the part that we know, and then this is the part that we don't know. So we can use that segmentation postulate in a little bit different way. Shall we? Because we didn't know the two parts. So in this first example, we knew that DE was 2 long, we knew that EF was 7 long, and they asked us how long is the whole thing, right? So we have to add those together to get 9, right? But here, they didn't tell us this part. We didn't know how long that was. They told us this other part was 33, and they told us the whole thing is 41. So if the whole thing is 41 and one part is 33, the way to find the unknown part is to subtract them. And then the last one, if DE is 14 and DF is 37, can we find EF? And that's the same way. So DF is the whole, right when I'm ready. So they give us the whole, and they give us the part. I'm not going to relabel again. That's too much. I'm not going to draw it again. We should know the whole, which is 37, minus the part, which is 14. It's going to give us the other part, which is, or that part, you can see 23. Any questions on that one? We are transitioning here to a little bit of algebra use, right? So that's an equation up there, kind of a formula. You're going to be writing equations based on these diagrams, and then solving to find the length of those parts or the length of the whole. So that is what we're working for today. Y'all kind with me? So everybody read that example 8. It was sure stuff under the device a little bit. I think I almost tripped over it a time or two, tripping to them. They asked us to find X and PM. So that's a segment with no symbol over it. So what does that mean I'm finding? Sorry? So we're out. What am I finding? What do I need to know about the line segment if I don't see a symbol above it? Yes, the distance or the length of that line segment. Yes. So we need to know what is X and what is the length of PM. And they don't tell us what PM is. So they give us enough information to find X and then to use X to find PM. We know that whatever length PM is 7 times whatever value X is. So that's what we're looking for. So these are the two things we're finding. We're going to use that addition, segment addition postulate. We know that PM NQ is equal to PQ. So that equation I wrote says the length of PM plus the length of NQ equals the length of PQ. I don't know what this is, but I have an expression that represents that length. That is X. I don't know what NQ is, but I have an expression that represents that length. I do know what this is. And it's the whole of 45. And now we have a relatively simple equation to solve. We're going to combine our like terms and solve for X. So 12X minus 3 equals 5. We'll solve this pretty quick because we just went over this. Divide both sides by 12, and now I know that X is 4. I know that X is 4, and now I can find what PM is because PM is 7 times 4. So PM is 28. So this example gave you all the information, and then they labeled your diagram or labeled the picture for you. So they did some of the parts for you, right? The next one is basically the same kind of problem, but they don't label anything for you. So that's what we're going to do. We know we need to find Y, and we need to find the length of AB. We know that B is in between A and C, so fortunately we didn't have to draw that part. They just give us the segment and all that. Then they tell us that AB has a length of 5Y minus 1. They tell us that BC has a length of 4Y plus 2. And they tell us that the whole thing has a length of 28. And now we can use that to write an equation. Anybody want to tell me what that equation would be? What do you think? Vivian, any idea? So let me help you. So it's going to be AB plus BC equals AC. If you'll get in the habit of writing that, now all I have to do is look for AB. So what is AB, Vivian? Perfect. Plus, what is BC, Vivian? Do you see how that makes it a little bit easier? So what does it equal? Yes. And so that makes it a little bit easier. You will go ahead and give yourself the formula there. Well, what is AB? Well, what is BC? What is AC? So we're going to add, combine by terms, 9Y constant plus 1 equals 28. Now we're going to plus 1 on both sides. We know what 9Y equals 27. It's easy to do this, which we should know. And now we know the value for Y is 3, and we can plug that in to find the length of AB. This is 5 times Y minus 1. Now we know Y is 3. 5 times 3 minus 1. So now we know AB is, what is AB? 14. I think we're doing okay on time. We should have enough time to finish our last two examples. Are y'all caught up with me? Give it a second. Darren, you good? Kellen, you good? Sarah, you good? Okay. What does the word congruent mean? We actually use this word in one of our definitions. Congruent means the same length. It also means the same size and the same shape. So it can mean any of those things. For a line segment, it means the same length. And if it's a rectangle, it means the same size. It means the same shape. No circle can be congruent to a square. Okay. So congruent. So in figures, in geometric diagrams that we're going to use, it indicates parts that are congruent, parts that have the same measure with different numbers of little dashes or hashes, whatever you want to call them. So 2 dashes here and 2 dashes on another segment in the same diagram tells me that they have the same length. I don't know what that length is from that diagram, but I know it's the same. Okay? Looking down here in this example, I know that segment CR, has the same length as segment RQ because it has one dash here and one dash here. Now, one dash versus two dashes doesn't mean one is longer and one is shorter. It just means they're different. Right? And it really only means they're different if they're on the same diagram. So, the number of dashes matches up the parts that are congruent. Okay? The segments that are marked the same are the same, or they are congruent. They have the same length if we're talking about segments. Segment bisector. Does anybody know what a bisector might be? Use some clues here. Clues BI. Two, right? Bicycle. Bipedal means they have 2 feet. Bimodal means they have 2 ways of being, 2 ways of transportation. Can you think of another bi? Okay, we can all think of another bi. We've got the message, right? 2 parts. If we're talking about geometry, though, a bisector is got to split into 2 equal parts. So when we talked about a midpoint before, if we have a segment bisector, it's going to be a midpoint. Right? So if we have a line, a point, a line, or a ray that bisects a segment, is going to split that segment into 2 congruent parts. So our segment can be bisected by a point, a ray, or another segment. In our example right here, segment PQ is being bisected by line FR. The point where they're intersecting, what's the point where they're intersecting? What point are they intersecting at, Corey? R, yes. And if that line is a bisector, that's going to make point R is midpoint. We don't know what the length from R to P is, but we know that it's the same as the length from R to Q. Y'all follow with me? So, we have 2 segments, and they are bisecting one another. We know segment AB being bisected by segment BC. So that point E is in the middle of A and B, and we know because this has 1 dash on each segment. One part has a dash, the other part has the same number of dashes. That means they have the same length. We don't know what the length is, but they have to have the same length. That makes E the what? What do we call E? The midpoint. AB is also bisecting segment BC. It is bisecting at the same point. We know that BE equals BC because those 2-part segments have 2 dashes, right? We don't know that BE is any longer than AE though. It's just different. So we're going to use some version of the segment addition postulate here. Exercise 10, example 10. So AE equals 30. And ED equals 2x plus 6. If that's true, what is x? So I can't use the segment addition postulate here, but I can use the fact that any of these 2 things are equal. So when we're talking about the actual figure, we say congruent, but if we're writing an equation, we can set them equal to one another. So we know that AE is equal to the distance, or the length of AE is equal to the length of ED, so we can say that 30 is equal to 2x plus 6. And solve for x, because that's all they asked us to do. So subtracting 6 from both sides, 24 equals 2x, divide both sides by 2, and x equals 2. So if we wanted to know how long, well, we already know how long CD is because they have the same length. We already know it's 30. Example 11 is similar, but not the same, since we knew what parts, the length of this part. We don't know the length of either part, but we know that BE, 6x minus 7, and EC, I'll put it here, 5x plus 1, we know that they're equal, right? So we write our equation. BE, 6x minus 7, equals 5x plus 1. And now we have an equation that we've been solving for about a week and a half. We're reviewing solving. We get our variables on the same side. We're going to subtract 5x from both sides. Our root's too big, so I'm going to switch mine over here, but that's going to be x minus 7 equals 1. Add 1 to both sides. Add 7 to both sides. And x equals 8. Now you'll notice I wrote the equation and solved for x, but it didn't ask me for x. I should have reminded you that if we know what x is, then we can plug it in to find either part, right? So if I know that x is 8, now I can find that BC here. I can find out how long that is. So I can take BE plus EC, and it's going to equal BC. The other way I could do that is I could find the length of web and then multiply by 2, right? Because they're the same. So I don't have to confuse it with things. So let me remind you guys of our postulate here. We're going to be BE plus ED. Oh, I lied. BE plus EC. Let's do the same thing as BE plus EC is equal to EC. So if I know what BE are and I know what EC are, I know what the whole length is. Does that make sense, Thomas? But I know the BC and EC are the same thing. So if I find the length of one, I can just add it to itself or multiply it by 2 because they are the same length. So let's just find BE. The BE is 6 times 8 minus 7. So 48 minus 7 is 41. So that's just BC, right? Now, that's just BE. Now I know that BC is 41 times 2, or 82. You're ready? Let me finish this last one. So I'm gonna make a new little line here, so it's not confusing. So AD, A, E, C. Draw a line through that. Let's go and start labeling. So we're speeding things up. You guys should be able to label now. AE is 8x plus 11. AD is the whole thing. So AD is 2x plus 10. So we can do this a couple ways. We know that these are equal. So we're going to run out of time. I'm going to kind of speed through it. We know that 2 of these, so 2 times 8x plus 11 is the whole thing. Does that make sense, everyone? Does that make sense? And we know that it's equal to 20 times x plus 10. You say no? No? Correct. So they told us that A, B, and C are congruent. Right, Letty? So if I know that, then I know that they have the same value. Right? So I can use that and solve the equation. Make sure you solve the equation before you submit it. Leave it blank. I don't give you credit. You write a lot of stuff down. If you're not sure on the educational policy, you know, look at the recording. Yours should be right. I'm solving it now.
What number 9?
Andre, right? Good. Good. Thank you. Look at my door closing. It's still great.
I see watching Facebook such a paper. Really, I just go. I want to be on the other side of paper.
Please pay attention to the directions of the board. You'll a lot to get done today. Barely finished either period. Put everything here, put your phone in the side of your phone. Right there. Yep, and control. Your computer. Look on paper. Okay. Thanks. Did somebody grab calculator 11 by accident? Everybody check the calculator. Oh, no, you're in your desk. Somebody just put it away like they were supposed to. What does do? Whether you did it or not, get out the paper. Lovely. All right, guys, I need violence and speech. Lee, were you just out yesterday or were you out the day before? Just yesterday? So you probably need to take a test today. We didn't do anything new, and we already have 1 day review. Okay? So you're going to put your stuff up here, Lee, your phone and your calculator spot, so we can take the test. We did notes online Tuesday, yeah. Okay. And the volume doesn't work, but you can watch this video. I'm going to recap on this video today. The volume. Oh, I forgot to end my video. It's going to be really long.